So if we look at the internal workings of the system here, that, as we said in a previous lesson, that the heat pump consists of four main components. Number one is the evaporator. So that is your outdoor coil, so that'll be outside your house. So that in an air source heat pump, that'll be a heat exchanger with a fan on an air source heat pump, or that could be your ground loop in a ground source heat pump. You have your compressor. So the job of the compressor is to compress the gas or the refrigerant that is in this loop. And then you have a condenser, and the condenser is the indoor coil inside your house, and this is where you transfer the heat that's in the fluid to the application that you require. So it could be domestic hot water, it could be space heating. And then we have an expansion valve that expands the gas as it goes around the loop. So, point one, at the beginning of the cycle, the refrigerant is in a liquid form. So it's a gas under pressure, and it becomes a liquid, just like propane in a gas bottle. So it's like a liquid LPG, liquid propane gas, or liquid petroleum gas. So the refrigerant, being under pressure, although it's a gas, will be in a liquid form, and that's what goes through this heat exchanger here. So it's your refrigerant liquid. Now your refrigerant liquid is very, very cold, and it enters the evaporator coil that's located outside your house or passes through a buried ground loop. And basically the heat then in the outside air or in the ground is taken up by the cold refrigerant. So you must remember the refrigerant is very, very cold, but it will take up the heat of the cold air outside. At point two, in our little schematic then, after the refrigerant leaves the evaporator section, it comes down the pipe here, through our reversing valve and into our compressor. So after the refrigerant leaves the evaporator section, it has the absorbed heat that is taken from outside. So it's changed then from being a liquid into a gas, comes up to the compressor, and just like when you heat water in the stove, it becomes steam. So basically it converts from being a liquid into a gas, and the evaporated gas then comes around to the compressor. Then what the compressor does is it does the compression cycle. So the gas, once it reaches the compressor, is mechanically pressurized in a compressor. So that basically compresses the gas, and that process increases its temperature so that the refrigerant then leaves the compressor as a hot gas because it's been compressed. And basically it's taken the cool, sort of cold gas, compressed it, and then it leaves as a hot gas outside the compressor. At point three then, as it exits the compressor, the refrigerant moves on to the condenser coil, which is located inside the house, or as a heat exchanger coil inside a hot water cylinder. So that's this item 3 here, so that's your indoor coil. Because the internal temperature is lower than that of the hot gas, the heat is then transferred or ejected from the refrigerant gas that's hot now in the coil to the outside air or into water flowing through the heat pump for domestic hot water or heating. So the hot gas basically expels its heat at this point at the evaporator. And as the temperature of refrigerant gas cools, it converts again from a gas to a liquid and a condensate, and basically that's why that's called the condenser. So it comes in as a hot gas, goes through this system, dispels its heat into the application, and then exits your condenser as a liquid form. And again, that's why that side is called the condenser. It condenses it from the gas back to a liquid. At point 4 then, as the refrigerant leaves the condenser coil, so it'll leave it as a relatively warm liquid. So it'll not have expelled all its heat into this, so it'll be a warm liquid. And this warm liquid refrigerant is made cold again, so it can absorb more heat. And that happens in the expansion valve. So expansion valve drops the pressure on the warm liquid and thus drops the temperature. So the pressure then, as it goes across the expansion valve, drops, and as that drops, the fluid again becomes cold. Refrigerant then leaves the expansion valve again as a cold liquid, ready to repeat the cycle again, and it goes into the outdoor coil to take up some more heat again, either from the air or from the ground loop. So, as we said previously, a heat pump can also operate as an air conditioning unit by simply reversing the cycle. So what we had a look at was heating mode in the slides there. by simply reversing the flow through the compressor, you can actually turn it into a cooling device or a conditioning unit. So you can actually see that on the evaporator side, inside the house, it's cool in this particular application and it's dumping the heat outside. So that would be an air conditioning mode. And then in heating mode, you can see the evaporator inside the house is hot and the outside is cold. However, to access UK government funding, financial schemes for renewables, technology manufacturers are generally obliged to disable the cooling mode in the hardware and or the software of the heat pump, such that this cannot be run, because the government does not want incentives to be used for putting in air conditioning in people's houses. The heating is what the renewable heat incentive is intended to target.